This video shows an introduction to Lab 4. We will learn about this device called the function generator to generate AC signals, and then we will try to read out the signals using this called oscilloscope. Let's start with the oscilloscope first. Now, as you can see here, there are buttons everywhere, and the equipment that we use with the oscilloscope is this thing called probe. So other than many buttons, we still have probe to take care with. Right. Let's turn on the oscilloscope. Now these probes, make sure that you use the correct one. They are designed for oscilloscope. If you look closely, this is the ground, and then this is the signal, right? And then we can kind of squeeze to expose the clipper, right? Let's connect this to channel 1 of the oscilloscope. Here you can see that just align this slot here to the BNC connector of oscilloscope. Right. If it is not aligned, then we cannot fully insert it. You may turn a little bit and then fully insert them, right? And with this is not enough because we can still pull out. We have to press and then turn clockwise until you hear the click, right? And at this point, it is quite sturdy. And to remove, do not pull out violently. Do not shake it. Just do like this. Slightly push, because this is like a spring. Slightly push and then turn counterclockwise. Then the probe can come out easily, right? Do not force them because you will damage this oscilloscope connector. Now let's insert the wire, and then there's a calibration signal here. Just hook this probe to the calibration. Now, if this oscilloscope somehow appears some screen like this, or the channels are messed up, then we can clear the configuration by pressing default. Right, just press default, and then this may happen, but now with our calibration signal, we can use the auto setup mode of the oscilloscope. And then this will show the signal here. And if you can notice, this probe is not that good, right? If we shake this, if we shake the probe, the wire, it's somehow slightly distort the signal. See the effect, right? This should not happen. So change a new one. And I have another one here. Let's test it. Plug into the channel 1 calibration. There you go. This is a working probe. All right. And also for channel 2, this is dual channel, so we can plug in to channel 2 and then press 2 here to turn on the channel. If it does not turn on, just press it again. It should turn on. And then for channel 2, do the same thing. Clip this to the calibration to test channel 2. And if it is like this, do not worry, press auto setup. Now, since channel 1 is the main one, we may connect this together to see, and then press auto setup. Right. Yes. Now this should shows 500 millivolt per division. So this is our calibration signal. It is a square wave with a frequency of 1 kilohertz, right? This here shows the time between each square of the time axis, of the x-axis. So it is 200 microsecond, right? This is 200, 400, 600, 800, and then 1000. So we complete one cycle in 1000 microseconds or 1 milliseconds. So our signal is 1 kilohertz. And then we can see from this here, we can see from this line to this line. If we count the number of the blocks, we can count 1, 2, 3, 4, 5, 6. So it's 6 times 500 millivolt per division. 6 divisions times 500 millivolt equals to 3 volt. So now we can get the 3 volt peak to peak signal. The next thing to take care is that there's a switch here. This switch indicates the attenuation of the probe. So for example, if I slide this switch here, let's see the effect here. Or if I slide another channel that's below here, you can see that the signal get attenuated, right? So make sure that your probe is at 1x. Here 1x, not 10x. Also for this one, the switch should remain at 1x. And this is how you can test the oscilloscope and the probes.